Hello. Today we are going to discuss all three forms of a quadratic and how to find the characteristics within each. So feel free to pause, fast forward, rewind if needed throughout the lesson. Okay. And these are the three forms that we are going to be looking at as a quadratic. So, we've discussed prior standard form, this ax squared plus bx plus c. Last week, or last class, we discussed very quickly vertex form, and today we're going to extend it to factored form. So we're going to touch on all three forms and how to find their characteristics. Okay, so let's start with standard form. All right, so for a standard form quadratic, if I'm looking for the concavity of a quadratic, I'm looking mainly at the a value or the leading coefficient. Okay, so this value that's up front basically tells me if it's concave up or concave down. Now, if that a value is positive, it's concave up. If that a value is negative, then it has to be concave down. In this case, our leading coefficient for the quadratic term is a -2. So we can make the conclusion that this function has to be concave down. Now, prior to even looking in my calculator to see what this looks like, I am fully aware that my calculator, excuse me, let me get my pen to work, is going to be a parabola opening downward. Okay. Now, the y-intercept for this, now we find the y-intercept the same for every form. I'm going to substitute 0. So again, I'm going to substitute 0 in for x. So if my function is a -2x squared plus 8x minus 11, to find the y-intercept, we always substitute zeros in for our x values. And when I do that, -2, 0 squared is still 0. 8 times 0 is still 0. 2 times 0. A lot of this quadratic goes to 0, and I'm left with only the -11. So if you substitute in 0 and reduce it, you get -11 as your answer. So my y-intercept is going to be 0, comma, -11. Okay, I know that not only is this graph going to open downward because it's concave down, but it's going to cross the y-axis at a value of -11. Okay, now there are two other characteristics that we are going to discuss for standard form, and that's axis of symmetry and vertex. So still standard form, last two characteristics. So the axis of symmetry, we have a formula. You can see it written in the bottom of your screen, but I'll write it again. Opposite of b over 2a. So when I write that little negative in front of my variable, that means I want to take the opposite of whatever that value is. So you're probably wondering, well, a, b, c, right? What are you talking about? Well, a, b, and c are referring to the values, the coefficients, if you will, in front of each term in my quadratic. So in this case, if I do the axis of symmetry, I want to start with the opposite of my b value in the numerator. Well, my b value is an 8. That's the middle term. Not the 8x, just the 8. It's just a number. So I'm going to say the opposite of my b value is a -8 all over 2 times my a value, which is a -2. Now, we don't take the opposite of a, only b. So now if I reduce this, I get a -8 over 2 times -2 is a -4, and -8 divided by -4 is 2. Now here's the catch. I need you guys to write the axis of symmetry is a line. It's that line that goes through the vertex. So this axis of symmetry has to always be written as x equals, it's an equation, in this case 2. All right, now let's go to the vertex. So the vertex, you must find the axis of symmetry first. So if I ever give you something in standard form and I ask for the vertex, the first step is to find the axis of symmetry. So I'm going to write that here. We know the axis of symmetry is at 2. So now what I'm going to do is I'm going to substitute that 2 into my function. So I'm going to write my function down real quick. And I'm going to take 2, and everywhere there's an x, I'm going to substitute in that value. So now I try to reduce. So I have a negative 2, times 2 squared is 4. 8 times 2 is 16, minus 11. So I would get a negative 8 plus 16 minus 11. And if you reduce this, I'm going to end up getting a value of negative 3. So my vertex, well, the x value is always the axis of symmetry, and the y value we just found is my negative 3. You must substitute in the axis of symmetry to find the y coordinate of your vertex. Okay, please pause, rewind. Okay, make sure you understand how to find the vertex of a quadratic in standard form. Okay. All right. So that was everything for standard form. So now we're going to shift to the next one of vertex form. Okay. Still a quadratic. You can still see that we are dealing with a squared term, or in this case, a squared grouping, right? And we're going to find all of the same characteristics: concavity, y-intercepts, axis of symmetry, the vertex. We're going to find all of those values still. Now, just like the other one, the a value, or the coefficient in front, okay, is going to tell me concave up or concave down. The y-intercept, we are still going to set x equal to 0. Now the axis of symmetry is a little quicker. We don't have to really do too many calculations. It's just going to be the opposite of my h value, x equals. And then the vertex is going to be the same opposite of my h value, comma, my k value. Okay? And you can get that k value from this term at the end. Okay? So let's see it in work here, okay, with an example. So I have something in vertex form, okay, and you can see that I have a negative leading coefficient. So because that's negative, I know that this is going to be concave down, or it's going to be a parabola opening downward. So anytime you have a negative value, it's concave down. Anytime it's positive, it would be concave up. And the y-intercept, okay, we can just set x equal to 0, just like we did for standard form. So if I write my function and I reduce that function, now you have to use order of operations, so we're going to start with our parentheses. 0 minus 1 is a negative 1 squared plus 9. Negative 1 squared, now be very careful here, negative squared is always positive, so negative 1 times negative 1 is a positive 1. Then the multiplication, negative 3 times 1 is a negative 3. And add, I get 6. So my y-intercept is at 0, 6. So this function, prior to even putting in the calculator, I know it has to open downward, and I know that it has to hit the y-axis at 0, 6. Okay? Now, here's another one, right? So I want the concavity and the y-intercept for this function. So feel free to pause. Try to do it on your own. So I have a positive coefficient, so that's going to be concave up. And my y-intercept is going to be 5 times 0 minus 2 squared minus 16. 0 minus 2 is a negative 2 squared minus 16. Now I do my exponents. Negative 2 squared is 4 minus 16. 5 times 4 is 20 minus 16, and 20 minus 16 is 4. So my y-intercept is going to be at 0, 4. All right, so whenever we find a y-intercept, we just substitute in 0. Okay, and again, that is my y-intercept. All right. All right, last two characteristics for vertex form. Axis of symmetry. Now, I had explained earlier on a slide that the axis of symmetry is just the opposite of your h value. So if you look at the very top, you're going to find that h value inside the parentheses. So my axis of symmetry is going to come from this 1. Now, you have to be careful because it is minus 1 in there, but we want to take the opposite, always the opposite. So I would use a positive 1. Okay, so for your notes purposes, your axis of symmetry, when we're dealing with vertex form, is always x equals the opposite of h. Okay, slightly different than standard form. Remember, there's a formula for standard form. When it's in vertex form, we're going to do the opposite of the h value. Okay, now the vertex, okay, we are going to use, so I'll write a little note here. The vertex, we're going to do the opposite of h, comma the k. Now you can look at the formula at the top. You can see h and k. My vertex has to be positive 1, positive 9. Now we do not take the opposite of our k value. So that is a very common mistake that people do. So we do the opposite for h, but we keep this k value the same. We do not take the opposite of this number at the end. Okay? So let's do one. Feel free to pause. Okay? You can try to do this one on your own. All right. And my axis of symmetry is going to be x equals a negative 4. And my vertex is going to be that same negative 4, comma, the k value, which is 7. Okay? So we can find the axis of symmetry. We can find the vertex from vertex form very quickly. It doesn't require any calculation. The only thing that you need to remember is that you need to take the opposite of the h value. Okay? All right, last form. This is the new one. Okay, factored form. All right, so factored form, we have this R1 and R2. And ultimately, that factored form, these values in here are going to be the x-intercepts. Okay, so that's really the only difference. Now, there are some different calculations that need to be made. All right, but we will go through them step by step. Feel free to take notes, to pause. Again, new form, new notes. So we're going to find all the same characteristics except for, because factored form lends itself, we can find the x-intercepts as well. So we're going to find not only the concavity, the y-intercept, the x-symmetry, the vertex, but we're going to find the x-intercepts for that function as well. So now if you take a look at this, we're going to start with concavity. Works the same way as all the other functions. We're taking a look at that a value that's on the top, right? So that a value tells us if it's going to be concave up or concave down, right? So in this case, it's the first problem here is positive, so we know it has to be concave up. Again, anytime you have a positive value, it's going to be concave up. And anytime you have a negative value, it's going to be concave down. Okay? So here, because we have a negative value out front, we know that that parabola has to open downward. So concavity works the same as all the other types of a quadratic. We're looking at that leading coefficient. We're trying to determine, is it going to be positive, concave up, or negative, concave down. Next is the y-intercept. We are still, excuse me here, we are still going to set x equal to 0. All right, that does not change. We've done it for all three forms. So if I take this, it'd be a 0 minus 2, a 0 plus 1. I'm going to substitute all my x values equal to 0. So now you have to follow order of operations. So we're going to do parentheses. 0 plus 1 is 1. And then I can multiply all three of those values together. So 3 times negative 2 is a negative 6 times 1. That's still a negative 6. So my y-intercept is going to be 0, comma, negative 6. Okay. Now, do it one more time. Let's find the y-intercept. I'm going to say a negative times 0 plus 1. 0 minus 9. Order of operations, I'm going to simplify those groupings. So 0 plus 1 is 1. 0 minus 9 is a negative 9. And if I do a negative times 1 times a negative 9, that will give me a positive 9. And I get my y-intercept of 0, comma 9. So again, different form, but same method to find the y-intercept. We always just set x equal to 0. Okay? All right. Now, x-intercepts. When I find the x-intercepts, and another word for that is zeros. Okay? So your x-intercepts are going to be the opposite of these values. Okay? They're going to be the opposites. So I'm going to say here that I know I'm going to have a negative R1, comma 0 and a negative R2, comma 0. Again, I put that negative out front to remind you that we need to take the opposite. Okay? So if I do this, I'm just looking at my problem. I know I have x-intercepts at 2, 0 and at negative 1, 0. Now, where did those numbers come from? Well, they came from the values inside my parentheses. So when I have two groupings multiplied by each other, that is factored form or intercept form. And I am going to then take the opposite of those values, and those give me my x-intercepts. Okay? Now, for the next one, if I do the same thing, I'm going to say, well, this piece is going to give me a negative 1, comma 0 as an x-intercept. And this piece would give me a positive 9, comma 0 for my other x-intercept. Okay? So when you're finding the x-intercepts or the zeros, another word for x-intercept is zeros, in case you see that, we are just taking the opposite of the constant that's within each group. So we're taking the opposite of this positive 1. We're taking the opposite of this negative 9. And those are the 2 points where my graph will cross the x-axis. Okay? Now, the axis of symmetry. The axis of symmetry is always right in the middle. Okay? So what we need to do when we find the axis of symmetry of something that's in factored form is I need to first find my x-intercepts. Okay? Which we did on the last slide. Okay? But my x-intercepts are going to be at 2, 0 and at negative 1, 0. Okay? So we're always going to find the x-intercepts first. Then we want to determine the middle of the two x-intercepts, right? We want to find the center of them. We want to know where the middle of those two are. So what I'm going to do to find the middle, just like if you were to have two test scores, an average two test scores, right? If I'm going to find the middle of two values, I'm going to add them together. So I had one at 2 and at -1. So if you add your two x values together and divide by 2, that's going to find the average. That's going to find the middle. So 2 plus -1 is 1 over 2. And if you divide that, you get 0.5. So my axis of symmetry is at x equals 0.5. Okay, so at 1/2. All right, that would be the location of the axis of symmetry. So let's do it one more time just to make sure that you follow. So my x-intercepts are at -1, 0, and 9, 0, because again, those were the opposite of what's in there. Now we want to find the middle for the axis of symmetry, so I'm going to take the first x-intercept plus the last x-intercept and divide by 2. Again, we're finding the average. Okay, so -1 plus 9 is 8 divided by 2. And if you take 8 and divide it by 2, you get 4. So my axis of symmetry is x equals 4. Okay, so this is different from any other form that we've done. Okay, so feel free to pause, rewind, rewatch. Okay, but when I give you something in factored form, we have to know that find the x-intercepts first and then find the middle of those two x-intercepts. Okay, now the last piece, all right, is to find the vertex. Well, if I find the axis of symmetry, so we had our x-intercepts, right? We're at 2, 0, and -1, 0. But then I found my axis of symmetry, right, by finding the middle of those two things. So that was 1 over 2, or x equals 0.5. We did that on the last slide. To find the vertex, we are going to take and we are going to substitute that axis of symmetry in to my problem. So my function was this, and I'm going to substitute. I want you to see everywhere there's an x, I'm going to put in the axis of symmetry. So now what I get is I get 3 times 0.5 minus 2 is a -1.5, and 0.5 plus 1 is a 1.5. And if you do this, now I would use my calculator, and actually I'm going to go grab my calculator. Sorry about that. If I do this, if I type in 3 times a -1.5 times 1.5, I get a value of -6.75. Okay, so my vertex, I'm going to write it out here, has the x value of 0.5, and it has the y value of -6.75. I don't know if you guys have realized this, but the x value of your vertex is always your axis of symmetry. Okay, and then we can always take that axis of symmetry and substitute it in to find the y value of our vertex. Okay, so let's do it one more time. Again, we start with our x-intercepts. So I know an x-intercepts could be at -1, 0, and 9, 0. We're going to find our axis of symmetry by finding the middle of those two x-intercepts. So add them up, divide by 2. Give me 8 over 2, or 4. So x equals 4. Now to find the vertex, we are going to take the function, so negative x plus 1, x minus 9, and we are going to substitute in 4. So that gives me a negative times 5 times a negative 5. And if you multiply that, negative times 5 times negative 5, that gives us a 25. So my vertex is going to be at the coordinates of 4, because that was the axis of symmetry, comma 25. Those are the coordinates of my vertex. All right? So just kind of a review. Again, rewind, take a look at all 3 forms. Make sure you know how to find any of the characteristics from these 3 forms, and email me or let me know if you have any questions.